Hey, it's Mr. Cohen. We're back for more. Today we're going to talk first about polynomials. Now, last week we talked about factoring polynomials, but x squared was just x squared. In today's problems, we're going to talk about polynomials where x squared has a coefficient. So, for instance, we start with 3x squared plus 39x plus 108. Now, we're going to go back for a second to 5th or 6th grade math, the horror, and talk about greatest common factors. What we're going to look for is the greatest common factor of these three terms. So if we were talking about the greatest common factor of 8 and 20, that would be 4. If we were talking about the greatest common factor of 8 and 16, we would get 8. If we were talking about the greatest common factor of 8 and 15, we would have 1. And one last example, if we were talking about the greatest common factor of 8 and 12, no, let's make that 8 and 14, excuse me, we would have 2. Now, the one thing that these all have in common is that the GCF is always less than or equal to the smallest number, or the smaller number if there's only 2 of them. We're going to get to more of that in just a second, but in this particular polynomial, we have 3x squared, 39x, and 108. Well, 3 is a common factor, the greatest common factor of 3, 39, and 108. So we're going to factor that out, which means we're going to divide it out sort of using the distributive property in reverse. And when we divide each term by 3, we get 3x squared divided by 3 is x squared. 39x divided by 3 is 13x. 108 divided by 3 is 36. We can factor this part into what multiplies to 36 and multiplies to 13 would be 9 and 4. So if this number is a positive, then we're going to factor it out and just deal with it in that way. Now, in the next example, and by the way, the textbook doesn't have a whole lot of problems like this, so I'm going to give you 3 at the end, and you can email me for the answers, or maybe I'll post the answer somewhere later. In our next one, we're going to take negative x squared plus 9x minus 20. Well, if there's a negative sign there, we know from factoring it's going to be much easier if x squared is positive. So what we want to do is we want to factor out that negative. This is like multiplying the whole thing by -1. So we're going to divide everything by -1. And we're going to get x squared minus 9x plus 20. Here's a polynomial in the parentheses that we can factor. What multiplies to 20 and adds to -9, we'll get x minus 5 and x minus 4. Now, make sure that you keep that negative sign. Make sure that, like we kept the 3 up here, because in a different video later today, I think we're going to talk about solving polynomials, and you need these as the polynomials get more complicated. The last part of this kind of problem looks like this. Now we've got the negative sign from the red problem, we've got a number from the blue problem, and they are together. So what we're going to look for in this particular problem is the opposite of the greatest common factor. The greatest common factor of 4, 40, and 96 would be 4. The opposite of that will be -4. Taking the negative out is going to achieve what we did in the red problem. So if we divide each term by -4, -4x squared divided by -4 equals x squared. 40x divided by -4 is going to be minus 10x. And 96 divided by -4 will be -24. So again, we get that set of problems, what multiplies to -24 and adds to -10. And the answer will be -12 and +2. Now, there aren't a ton of problems in the textbook that really work like this. Number 8 on page 536, number 38 on page 544. Here are 3 more. And again, I will have the answers for you. I'll email them, or you can email me, or we'll put them in another video soon. I'm going to stop this video and start another one. So thanks to my wife for filming it. Thanks to the dogs for not being around this time. And thanks to the frog over there for also being quiet. And we'll see you in the next video shortly.